When we're measuring growth, we need to recognize that there's a process that we're going to go through. And what we're going to look for is the percent change or the percent growth over a period of time. If we're just looking for year-over-year change, we can divide the difference of the two figures by the first year's value. In other words, we take the ending number minus the beginning number and divide it by the beginning number. Now there's a slightly simpler way to do that, which is simply to take the ending number and divide it by the beginning number and then subtract 1 from that quotient. I like the second formula a little bit better because it relates to some of the other computations that we do. So this is the one that I usually use in practice, and it's the one that I try to teach students to use. If we're going to measure growth over more than one period, that means we need to find kind of the average growth during that time. The compound annual growth rate, or CAGR, is really just the average rate of change that happened during a set of compounding periods. Now, earlier in the quarter when we talked about compounding and discounting, the example I gave was an investment of $100 that was allowed to compound for 3 periods at 10%, and where we wound up with, what we wound up with was $133.10 result. If all I'm given are the ending value, the starting value, and the number of periods, I can figure out what that rate of change was by using the formula that's shown on the screen. So 133.10 is my end point, so I take 133.1, divide it by my start point, which was 100, raise that to the 1/3 power. I'm going to take the third root of this because there are 3 compounding periods, so the way I do that is to raise it to the 1/3 power, and then subtract 1 from the result, and I wind up with 10%. 133.1 divided by 100, raised to the 3rd power, or rather to the 1/3 power, is 1.1. Subtract 1 from that, I get 0.1 or 10%. And I can test that by plugging the result back into a compounding formula. I'm going to use all of the figures that I know and make sure I wind up at the right end point. I should end up with $133.10 if I use that 10% in a compounding formula. $100 times 1 plus my 10% raised to the 3rd power. So I'm going to take my 1 plus my growth rate, which is 10%, that's 1.1, raise that to the 3rd power, and then I'm going to multiply that by 100, and I get $133.10. I wind up in the right end point, so I know I've done the computation correctly. The other way you can find this is by using the TVM functions on your calculator. Some people find this easier. If we know we started with $100, that would be our cash outflow. Future value is where we end up, which would be $133.10. 3 periods involved, so n equals 3. There are no intermediate payments, so 0 for the payment, and we solve for I and come up with a 10% result. There's another circumstance that you need to be aware of, and that is you might be given a set of annual percent changes rather than dollar figures. And there's a way to figure out the annual growth rate that's implied by this by finding what's called the geometric average. So imagine this situation. What if you made an investment in 2009 and you were given a series of annual percent changes instead of dollar figures? By the end of 2010, you had gained 20%. 2011, you lost 16 2/3%. 2012, you gained 20%. 2013, you gained 16 2/3%. If you were going to figure out what the average rate of change was, you'd need to find the geometric average growth over the 3-year period. And the next slide kind of illustrates the hows and whys of this. The numbers that would work to give us those percentages are shown in the top there. If we have a share price for each of those years, in 2009 you might have bought at $10, in 2010 it was worth 12, in 2011 it was worth 10 again, in 2012 it was worth 12 again, and in 2013 finally it's worth $14. If we take a look at what those average changes are, the gain of 20%, the loss of 16 2/3, the gain of 20, the gain of 16 2/3. If we were to just average those together, we'd get an average of 10%. 20 minus 16.67 plus 20 plus 16.67 divided by 4 is 10%. But we know that's not going to be the right result because if we plug that into our compounding formula, we won't wind up at $14 if we're averaging a 10% return. What's going on is we've got a compounded function, and so we need to find the geometric average of those percentages. To find the geometric average, we don't really care what the dollar figure was that was involved. We're simply going to add 1 to each of the annual percentages. So our first period gain was 20%, so we add 1 to that. We're going to multiply that by 1 plus each of the subsequent years' change. So 1 plus a negative 16.67%, 1 plus 20%, 1 plus 16.67%. If we multiply each of those pieces together and then take the 4th root of it, we'll wind up with 1.0878. If we subtract 1 from that, we wind up with 8.78%. So 8.78% is my geometric average. That's going to be the compound annual growth rate that I wound up with as a result of those numbers. And if I want to check that, I can compute it by doing the CAGR according to the prices. 14 is where we ended up and 10 is where we started. So if I take 14 divided by 10 to the 1/4 power minus 1, I get 0.878, which is 8.78%. If I wanted to work this out kind of on a step-by-step basis, what's going on is that I've got an 8.78% average increase. That's not the amount that it actually changed each year, but we wind up with the right final value if we treat that as the compound average growth rate. And because it was 5 years involved, we've got 4 periods of compounding, so we're only using the 4th root in our computations.